Assalamualaikum and good day to Dr. Jeffrey. My name is Nurul Athirah binti Abdul Halim and I will be presenting about the effect of different gas hourly space volume (GHSV) on methanol production plant, which is a consequence accidents analysis that is a part of my research project. So for the presentation, I will first talk about the abstract, followed by the objectives, problem statement, scope of study, methodology and result, as well as conclusion, recommendation, and lastly the acknowledgement, followed by references. The relation between high pressure and high reactor volume with different gas hourly space volume is quite remarkable, as high pressure and high reactor volume gives out low GHSV. In that case, different GHSV may alter the quantity of methanol inside the reactor, which will also affect the quantity, mass, and volume of chemical component inside the reactor. And any alterations made to the GHSV will also impact the safety of the plant according to the inherent safety concept. This research is conducted to analyze the impact from possible release of chemicals, carbon dioxide, hydrogen, methanol, and carbon monoxide by applying different GHSV of pressure 442 bar and the reactor size for plant 1, which is 42 meter cube, with a GHSV of 10,000 per hour. The plant 2 with a reactor size of 21 meter cube with GHSV of 20,000 per hour, and the reactor size of plant 3, which is 84 meter cube with a GHSV of 5,000 per hour. The location chosen to carry out this research for 3 methanol plant reactors is in Manjung, Perak. The case study is carried out by simulating the process reaction in high seas to get the mass flow rate prior to getting the number of fatalities during day and night of scenarios. And then Aloha and Marplot softwares were used to quantify the safety of the substances inside the plant according to the parameters of the plant location using threat zone analysis. The simulation was included with all possible scenarios in terms of toxicity, thermal radiation, and overpressure to evaluate the possible worst case impact. The leakage of the reactor used are 10 mm, 25 mm, and 160 mm. The consideration of day and night are taken alongside with 2 dominant wind directions in Sri Manjung, Perak. Distance and area plot threat zone are the resulting consequence scenario outputs, in which plant 3 gives out an overall of 257 fatalities for an area of 962 meter through 160 millimeter leakage, reactor leakage. Following research project 1, the objectives of this project is to identify the mass and volume fraction of each chemical component in the mixture for different GHSV on methanol production, and it is to quantify the safety of methanol plant using distance and area plot threat analysis for different GHSV. The relation between high pressure and high reactor volume with different gas hourly space volume GHSV is quite remarkable, as high pressure and high reactor volume means that the GHSV is low. So in that case, different GHSV may alter the quantity of methanol inside the reactor, which will then also affect the quantity, mass, and volume of chemical component inside the reactor mixture. And any alterations that are made to the GHSV will also impact the safety of the plant according to the inherent safety concept. Thus, detailed assessment must be evaluated earlier to determine the safety measures of the plant through consequence accidents analysis. This research is conducted to analyze the impact from possible release of chemicals such as carbon dioxide, hydrogen, methanol, and carbon monoxide by applying different GHSV at a constant pressure of 442 bar to plant 1, which has reactor size of 42 meter cube and GHSV of 10,000 per hour. Plant 2 with reactor size of 21 meter cube with GHSV of 20,000 per hour, and to plant 3 with reactor size of 84 meter cube and GHSV of 5,000 per hour. The the 3 methanol plants will be carried out for this research in Manjung, Perak, next to Sultan Azlan Shah Power Plant, so that the carbon dioxide that are released from the power plant can be used can be used as one of the raw materials for the methanol production plant. So the simulation will include with all possible scenarios in terms of toxicity, thermal radiation, and overpressure. And the leakage of the reactor that are used are 10 mm, 25 mm, and 160 mm, with consideration of day and night, with wind blowing from north and west. This study is carried out referring to the process condition of the reference plant by Perez Fortes in 2016 that studied about the potential impact of the production of methanol using carbon dioxide as raw material. The plant operates by capturing carbon dioxide from the flue gas of a power plant as raw material, implementing post-combustion method. So for this project, for the 3 methanol plants, first we need the value of pressure, temperature, and mass flow rate is input in HYSYS, and to get the density, volume, and mass fraction of chemical in the mixture for possible release. And then the atmospheric data of Seri Manjung is obtained using windfinder.com to get the air temperature, humidity, wind speed, elevation, and cloud cover, to simulate the chemical data and atmospheric data in Aloha. The next step is to determine the toxicity, thermal radiation, and overpressure, which is also in Aloha, and to obtain the threat zone, which is the distance of affected area in Aloha. Threat zone, which is the distance of affected area in Aloha, to be transferred to Maplot to get the footprint size, which is the affected area, to get the number of fatalities. The result comparison is done for the 3 plants, which is comparing the 3 plants according to both wind directions, which are north and west, and according to chemical events, and the highest chemical events that produce the highest number of fatalities is the toxic release of methanol. So according to the results in the table, Plant 3 causes the highest number of fatalities due to methanol toxic release event, which is the highest as compared to Plant 1 and Plant 2, caused by the same event for its reactor volume of 84 meter cube, despite the constant pressure of 442 bar. The larger reactor volume combined with a larger leakage size brings catastrophe, as methanol is a highly toxic substance in which it can penetrate human skin when it comes in contact, leading to metabolic acidosis caused by immediate blood acidity. And then the next comparison is the distance, the affected distance comparison, in which Plant 3, in contrast to Plant 1 and 2, imposes the furthest red zone distance for 962 meter following the methanol toxic release event, as the large reactor volume of 84 meter cube means that it contains more fractions of methanol as compared to other 2 plants. This leads to an extreme toxicity explosion, in which it also affects the inside and outside area of the plant, increasing the number of fatalities, which leads to 257 fatalities. And the event of toxic release of methanol caused most fatalities, as the explosion impact itself gives high pressure shock wave which can injure people nearby by blunt force trauma. Severe thermal burns from intense amount of heat due to the fireball from the explosion can also be fatal, apart from the inhalation of a significant amount of toxic vapor released into the air, leading to metabolic acidosis. As a conclusion, the Plant 3, with a reactor volume of 84 meter cube and a GHSV of 5,000 per hour, supports the following scenario outputs, as a lower GHSV means a slower flow rate of gas through the reactor, resulting in longer residence and reaction time, the time in which the duration that the gas component is inside the reactor, and it means that the longer residence time and the reaction time means that there are better conversion of reactants inside the reactor. This essentially means that the significant outputs are caused due to the high concentration of reactants inside the reactor during the leakage accident event. The simulation was initiated by the calculation of the mixture release by mass and volume fraction of the mixture components in HYSYS software, followed by simulation in Aloha for toxicity, thermal radiation and overpressure explosion to obtain the affected distance prior to obtaining the affected area for the number of fatalities using MAPLOT. To further develop analysis on this project, it is recommended to conduct further research on extremely low GHSV, such as 1,000 per hour and 2,000 per hour at higher reactor pressure for safety analysis. The second recommendation that I could employ in the future is that to employ recent advancements for the safety of production plants operating with high pressure reactions in other equipment such as distillation column or flash tank. I would like to express my deepest gratitude to the College of Engineering, University Technology Mara, as well as my supervisor, Dr. Muhammad Aizat Ahmad, for the facilities and the endless guidance and support that he has given to me throughout completing this research. Thank you.